Hi, this is Susie the tutor. Today we're going to learn about 6 transformations of a function using tables. Sometimes we have a parent function and we have a whole bunch of transformations to do to that parent function. And we're going to do worst case scenario and do all 6 today. But I want to show you how if you put it in a table like this, it'll make it a whole lot easier. The instructions say to graph y equals -3 times the square root of -2x plus 4 minus 1. You'll notice on the second line, the first thing we want to do is factor out anything that's attached to the x, whether that be a negative sign or a number or both. And when you factor that out, you just want to make sure that it multiplies back out to give you your original problem. Then we go through the 6 steps in this order. It's basically inside the function left to right and then outside the function left to right. So you can see step 1 would be the negative sign that's inside the function, and that is a horizontal flip or reflection over the y-axis. Anything on the inside of the function is horizontal movement, and anything on the outside of the function is vertical movement. So number 2 would be pointing to the number 2, which is a horizontal shrink, because everything on the inside of the function kind of does the reverse of what you think it should. And so 2 would normally look like a stretch, but inside the function it's actually a shrink or a compression, and you compress it by a factor of 1/2. You basically take the reciprocal of the number that's in that position. Number 3 is the thing that's inside the parentheses, which would be a -2, and again that goes reverse of how you think it should. -2 you would think left 2, but it actually goes to the right 2. Then you move to the outside of the function, and in this case it's the square root function. Outside you move left to right, so step number 4 is the negative sign. The negative sign represents a vertical motion, vertical flip, reflection over the x-axis. Number 5 is the 3 being multiplied in front of the function, and the 3 represents a vertical stretch by a factor of 3. The things on the outside of the function do as you think they would. A 3 stretches it by a factor of 3. Number 6 is the last one, and it's a vertical shift, which moves the graph down 1 unit because it is -1, and it does what you think it should. So let's get started graphing this. First, we want to start with the parent function. I chose numbers that are perfect square roots so that we would get nice numbers, and the square root of each one is as shown. Then we want to take the x value and the resulting y value and make ordered pairs out of them. So 0 gave us 0, 1 gave us 1, 4 gave us a 2, and 9 gave us a 3. So I'm plotting these 4 points on the graph and connecting them with a curve. That is the parent function for square root function. Now we're going to repeat these values in the x column for step 1. We are focusing on the negative sign that's inside the function, and we're going to make all the x values negative or opposite of what they were before. The y values are going to stay the same as the original chart. So our new values are in red, and we're going to graph them in red. And our 4 new points show this horizontal flip over the y-axis that we were expecting. So we're going to take all the new red x values from that chart and put them on a new chart in blue. Then we're going to do our second transformation, which was a horizontal shrink by a factor of 1/2. That comes from the 2 that is in this position, taking the reciprocal and multiplying that reciprocal 1/2 by each of our x values. The y values remain the same as they were in the original chart because we're only doing horizontal transformations right now, which affect our x values. Then we graph our new 4 points in red. And you can observe that it is horizontally shrinking by a half. What used to be 1 unit away is now a half unit away from the y-axis. What used to be 4 units away from the y-axis is now 2 units away from the y-axis. And what used to be 9 away from the y-axis is now 4.5 away from the y-axis. So everything got shrunk horizontally by a factor of 1/2. Then I take my new x values, put them in my chart in blue, and I do my next transformation, a horizontal shift right 2. You do the opposite of what you see there. -2 becomes +2 because the inside does reverse of what you think it should. You add 2 to all our new x values, keep the y values as they were, and then we plot these 4 new points. 2, 0, 1.5, 1, 0, 2, and -2.5, 3. And as you can tell, it looks like the blue graph just basically shifted over 2 units, and that's how it ended up on the red graph. So now we have completed our left and right or horizontal changes, and we are moving on to the vertical changes. This means that we're going to keep our x values locked in now, and our y values are going to start changing. So we're going to do things to our y values. So starting on the blue, which are our old y values, we're going to put new y values by making them all negative or the opposite. Now we're going to take our old x values and our new y values and plot those 4 points. As you can see, it looks like our graph did a vertical flip over the x-axis. Now I'm going to take my new y values and rewrite them in blue and work on the 3 that's being multiplied, which makes a vertical stretch by a factor of 3. So we multiply all our y values by a factor of 3 and then plot our old x values and our new y values on our graph. 2, 0, 1.5, -3, 0, -6, and -2.5, -9. You can see that our graph has been vertically stretched by a factor of 3. A point that used to be 3 away from the x-axis is 9 away. A point that used to be 2 away is now 6 away, and a point that used to be 1 away from the x-axis is now 3 away from the x-axis. The point that was at 0 is still at 0. Our last transformation is the -1 at the end. We take y values, subtract 1, and we get new y values. Combined with our old x values, we graph these 4 points. And as you can see, when we draw the new curve, it looks like the blue graph just basically got shifted down 1 unit. And we'll just take it and show you that it shifted down 1 unit. And where the blue is on top of the red if you just shift it down 1 unit. So those are the 6 transformations summarized here in a smaller table. So what you're going to do is you're going to split your x values and your y values of your parent function into a horizontal chart and a vertical chart. Our original 4 points are in blue from the parent function. Then we're going to look for the first transformation on the inside, that negative sign. We're going to put it in the first column of our chart and make all our values negative of what they were before. Then we're going to look at the 2, and the 2, we take the reciprocal, which is 1/2, and we multiply all our values by a half. Notice I'm taking the ones from just the column before. So 0 times a half is 0. -1 times a half is -1/2. -4 times a half is -2. -9 times a half is -4.5. Then we're going to do -2, which we actually do the opposite and put +2, and we take those previous values and add 2 to each one. So we've completed our horizontal transformations, and our red column is going to be the points we're going to use. Then we go over to the vertical side. On the outside of the function, we have a negative. So we take all the y values and make them negative or opposite. Then we take the 3 and we multiply all those y values by 3. 0 times 3 is 0, -1 times 3 is -3, and so on. Then we take the -1 at the end, and we subtract 1 from each of our previous y values. We've completed our vertical changes, and now our new y values are in the red column. So we're going to put them together, the two red columns for our x values and our y values, and we're going to graph them from there. Remember, this was worst case scenario, and you're not always going to have 6 transformations in every function, but this gives you the tools to take your parent function, put it into a chart, and graph the parent function, as you can see in blue, and then we will do all the transformations in a chart, the horizontal ones separate from the vertical ones, put all the red points together into a graph like this red one, which is the transformed function. It would have been hard to visualize how the blue version became the red version without these steps. So there you go. Thank you for watching my video on 6 transformations of a function using tables. I'm Susie the Tutor. Goodbye.